Thank you very much for coming. My name is Donatas, and I'm here to ask and answer one simple question. Do you really need that relational database? Let me ask, yes, thank you very much. How many of you start your projects or features or whatever from database structure? Raise your hands. Okay, that's around third-ish. And how many of you start from like modeling from user's perspective and how they're gonna use the thing? Okay, that's somewhat another third. So what are the last third doing? How do you start your projects? From where just writing code and then prototype. Okay, cool. So for me, for the bigger part of my career, I had this kind of a itch in the back of my brain. It's like, why do we constantly select data from the database which does not change? For example, we select the same news article constantly. We select the same product page when the data in there does not change, right? Why do we have a track of how many queries per second we do all the time when they're just fetching the same thing over and over and over and over? If you have a news article that does not update for like, I don't know, if it's not a popular article, it doesn't update ever. It's just there, what we selected. And then we have 20, 30, 40 queries per every single view, right? Why do we do that? And at some point I thought, okay, maybe that's because we start by creating projects from our database. Maybe when we start developing, you know, that's the first thing that we Google up. How do I create a dynamic website with PHP, JavaScript, HTML, and CSS, whatever. It's such a core thing for us that we don't even think about it, right? Like, I don't know, sleeping, eating, whatever. It's like, oh, I need to create this new thing. Now I'm just gonna create a database structure. Gonna make it third normal form. I'm gonna make it all relational because, you know, I need that. I clicked. So dynamic websites became kind of a synonym to connected to database websites, at least for me. The target of my talk here is for kind of medium and high traffic websites and the projects that you're working in, because for kind of a smaller things, what I'm gonna say does not make a lot of sense, and for very, very, very high traffic websites, there are more issues and more custom solutions are necessary. So just to keep that in mind. The other thing is that speed is very important. And this is just some quotes from the Google's article about performance. The perceived speed for users is very important because that increases your purchases, your orders, your conversions, your traffic. Everything is gonna better if you do speed. And I'm not related to BBC, but I just picked the website by default. Just an article. It takes 1 second to load it. And in my book, that's very slow, especially for a high-profile website like this. I don't know what they do there. Maybe they're using a relational database in the backend. Maybe not. It's not network because this comes from Frankfurt. I checked. So I don't know what's happening in there. Other example you probably know is also a little bit slow. I am slightly related to this, or was. And it also takes 1 second. And I know that is also using a relational database in the back, which is kind of slow. I tried to check some Dutch news websites, but they seem to be under 50, 100 millisecond response times, the article, so that was really good. So how do we stop relying on relational database for our user-facing apps? Well, let's go through that. Let's take a typical news portal, because that's kind of quite easy. And you kind of have in here multiple slices of the same data, right? So there's basically articles. Articles have categories, they have authors, dates, all that information. That doesn't really matter. But you have, for example, latest news, which are just in, and the same news article is in the main kind of block part, right? And you have another one, etc. So if you would model this in the relational database, you have, same articles, but they kind of filtered in a different way. So then you have to figure out how to create indexes for those tables, how to query them in a different way, because one is just ordered by date, the other one is sliced by some mysterious appear in the front page query or something like that. When you start slicing that data into kind of different blocks, it gets a little bit more complex. And it makes it difficult to kind of figure out what kind of queries you need to create. Because if you create indexes everywhere, that's not going to work, right? MySQL doesn't understand how to deal with indexes everywhere, or like one giant index of everything, right? But of course it can be cached. Yes, it can. But I think everyone can agree that caching is the most difficult problem in development, because, for example, how long do you cache an article? If it's a very big news, let's say storm rushing to Netherlands, you want it to be a short cache because you want to constantly update people about that, right? If it's some kind of pop star, did whatever, it will not be updated. So that's the regular news, and you want to have a longer cache for that. On the other hand, if you set a smaller TTL, you will constantly hit your database for kind of no reason, right? And that will create a necessity for more resources in your hardware. If it's too big, then your article is going to be outdated if it's constantly updated, and they're going to include mistakes or something like that. So it's going to be not informative for your users. The biggest problem I have with cache personally is that I have no control over my data. Absolutely no control. Once it's cached, you don't know when it's going to be updated. You don't know when it's going to expire, right? Like perhaps you have some kind of a traffic spike, and then suddenly 300 users are regenerating the same cache key. Why? Or if you make mistakes, you have no way of clearing that cache, at least in such a way that will not affect your performance. You probably won't clear just all of your cache if you have medium high traffic website. It's just suicide. Yeah, but that multiple users might regenerate the same cache, which is not what you want. Long time ago, I was kind of working on a news portal like that as well. It's already not existing anymore. And we were doing the same thing, right? We had a relational database behind, we had cache for everything, and suddenly there was like a riot near Parliament, and very unexpected, no one knew that's going to happen. Everyone goes to the news portals. Every single person in the country was trying to look up what's happening. Every single portal in the every single news portal in the country was basically dead. Like literally no news whatsoever, because everyone died. And We didn't have any containers, we didn't have any cloud providers, nothing. There was nothing like that back then. Fuck, sound old. And yeah, we died. And everyone wanted news. And we cached, that didn't help us. But the funny thing, we just thought, all right, so maybe let's generate that news page in our staging environment, save the output, put it into all our servers manually, and just leave it there. And that worked. You know, that really went well, and basically we were one of the first portals that came back up. It was the first or the second. And basically for the rest of the day, our job was to, journalists updated the article, we opened it in the staging, saved the output, pushed it into the production. Brilliant. That was really, really brilliant. But of course, that's not the way to go, right? We will not sit all day and F5 our staging environment and put HTML files to the production. So what else? How can we perhaps make a similar approach to manually pushing HTML file, but more automated and more smarter, let's say? And how do we decouple actually our news portal from the database? Basically this, make it static. The short answer is make it static. It's probably the quickest and the simplest way how you can decouple a project from the relational database, right? Maybe you have, I don't know, rendered HTML. Maybe you have a luxury of that. And yeah, just do that. And it will be super fast, etc. Of course, it's not that simple. What that file would contain is a read model. And that read model would look something like this. You would have a title of the news, you would have a specific format of time, that's arrival time, and the URL. And it's for a very, very tiny specific use case. But what is a read model? It comes from CQRS. It's just a term in there. But you might also know it as kind of an aggregate root in the DD. It has a similar concept and similar purpose. You might also know it as a view in a database. Because when you create a view for a very specific use case with very specific data. Conceptually, it's kind of the same. For me, it kind of means that it's a dataset specifically crafted for a single use case on the website. Like very, 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 very specific. So if we take our news website example, we would have read model in the just in section with title and timestamp, for example. We would have another read model which covers like the first page, first in the eyes block of articles. Another like most read, which again is similar data, which contains titles, URLs, but is sorted in a different way. Videos, this main header thingy, some other stuff. And basically, if you generate read models for all of those parts, you don't need a database for that. Eventually, if you do that, you will have faster response times, you will have more people in there, etc. But you think, okay, so have this project, it's maybe legacy, maybe new one, and you know what, I will have to write it again. So for 10 years, I was selecting everything from the database, and now you say, okay, you write this because this is wrong. Well, not entirely. Let's look at some ways how this is possible to achieve in a project that's already existing. The easiest and the simplest way for me is to create some kind of seams in your back office where you can then inject or emit certain events. So when you, for example, save an article, you can emit a certain event with the data or without the data, then hey, it's saved. And you can hook up afterwards. Right, I'm gonna go to that. That event might trigger a projector. Or you can decorate a class, for example. There are multiple ways how to achieve that, but basically this is the least amount of work you can do to kind of extend the system that you already have. Well, what is a projector? Projector comes from event sourcing, and it means that it's responsible to project an event stream to any kind of structural representation. So be it JSON, be it HTML, be it, I don't know, text file with just that in there. And it might look something like this. Again, it's kind of primitive and simple example, but if you have a legacy system, that's basically the most that you need to do, right? If you have your CRUD admin and your user-facing project in the same server, this is how you can achieve a complete disconnect from the relational database on the user-facing app. You just, when you save, you have that event fired, you listen to an event. When an article is saved, you can select all of the data that you usually select for the front page and just save it in the file. Primitive? Yes. Effective? Of course. Or render it if you have Twig. And the goal of the projector is to kind of achieve this result, which you will then display in the front page. And I'm not saying use event sourcing, because that's hard. I know it's been in the talks for the last couple of years, but no need for that. It's for different purpose. It might help you as well for this, but it's for different purpose. But you can use concepts from all of these different parts, right? You can use projectors from event sourcing, you can use read models from CQRS and kind of combine them together in some way that helps you to have faster performance and happier clients. When you inject it, kind of, when you have these events, when you have these seams all over your project, you can basically hook up anything in there, right? You practically have unlimited possibilities in there. You can convert straight into HTML. Whatever output you select from your back office, just do that. You can have the data processed through a queue if you have like bigger amounts of data, or you have a slow system, or whatever. You can hook up external systems for integration, etc. You might even have these external systems connected together with the projector. And you can project as many different formats from there as you want. Maybe you have a newsletter, maybe you have an RSS feed, maybe you have some kind of other push for the third parties or whatever, right? You can do anything in there basically. But of course it comes with a cost and a slightly catch. If you make a mistake, you will have to regenerate all of your read models. If you have a lot of them and you forget to add a certain property that your front end requires, you're going to have to regenerate everything. Depending on the situation, that might be challenging, that might be not, right? This kind of approach as well adds more moving parts, which in the end makes your project slightly more complex. Sometimes it's good, sometimes it's bad. But if you have a lot of small projectors, it becomes a little bit difficult to grasp how everything works. And of course, it sounds slightly backwards and slightly awkward. It's like, oh, okay, so now you're suggesting us to just generate a file in there. Eventually, yes. And this is kind of a challenge of like a very core knowledge part of what we learned from the beginning, I think. So what do we have in the end? We have our news portal. We have an event firing from our back office when a journalist creates an article. We have a projector which generates the read models for this, for every single use case that we have on the front page. And this kind of decouples this website from the database. And you don't really need a relational database for this anymore, for this part. How about a harder example, right? Because news portal is kind of simple, I think, for most part. Let's take an eShop. Yeah, I know, I like coolblue. A webshop has much more moving parts, much more content, much more wider structure. You might think that this might be something, a relational model of an e-commerce project.
It's an actual screenshot, right?
Sorry?
It's an actual made screenshot in the past, right?
No, no, that's not. It's close, but it's not. Fun fact, we actually printed the relational structure of coolblue back in the days. It took us basically like this section of a wall to put it, you know, like papers. So it's close. But basically you have overly complex structure. You have all the product information, categories, facets, filters, specifications, reviews, so on and so forth, so on and so forth. Which eventually makes it really, really hard to create proper indexes and to find proper queries, how to work with the structure. Because it's basically, I don't know, third normal form. So everything is in their separate tables, everything has connecting tables and so on. You might have queries which are super complex and super long. They might take 100 lines, 200 lines. And this is what I saw. They're really hard to work. Another thing that makes it much more complex for this kind of websites to have proper queries and proper database structure is optimization for the back office, right? You want data analysts to see how people are purchasing the data, which kind of introduces a very different set of queries to the system. And they are completely different from what you serve to the front end, because they want more details, they want more different slices, and so on. So how do you satisfy both of them, right? Because data analysts need indexes on, I don't know, maybe dates or something like that, but the front end doesn't need that. They have different queries. You could cache, again, but who has a project which has like an average cache hit ratio over 80%? Oh. Above 50%? Really? 2 people? So what's your average cache hit ratio? Okay, you don't know. Last time I remember it was, for me, somewhat around 60%, which is, I think, low. And that's because you don't know what to cache as well. Do you cache the product itself? Do you cache the lists of products? Do you cache both? Do you cache just parts of the product? Do you cache a title, images separately, description separately, price eventually? Just the price or with the product? What kind of TTL? Do you generate random TTLs for that cache, or just users randomly regenerating the cache over and over and over? It's difficult for such a big project, which then maybe brings the question that you don't really need the database for a product page. Maybe you don't need a relational database to fetch all that information, then add another layer of complexity to cache everything. Maybe it's possible to reverse that and generate that page when you save it. In this case, you can have a lot more read models for the product information and for all the related things. And they all can be generated when you save a product or when you update the price and etc. Basically, nowadays storage is relatively cheap, so we don't have to worry anymore about duplicating our data as long as we have a way how to update it when it changes. Right? We can generate, I don't know, let's say an average web shop has 40, 50,000 products, something like that. So triple, quadruple the amount of data that it has, and you still probably will not reach a terabyte limit, let's say. And everything there can be like duplicate lists and duplicate information, etc. Again, there's a catch, of course, to that. And you might have a situation where you have inconsistencies in your data. So the more read models you generate, the more problems you might have eventually. For example, there's a bag which costs 41 euros. You add it to the cart, 45. Ha ha ha. That's not what you want for your users. And this is not a very easy thing to handle, of course. So how to deal with that? How to deal with a lot of data? When you save a product, of course, you don't want to call a gazillion of services outside because that will kind of impede your people who enter the data or people who edit the data, and etc. You might utilize NoSQL streams for that. You kind of store the end result in a similar way as I showed with the news portal, right? You have some kind of a SIEM, some kind of an event fired, which kind of saves the final state of your product inside of the NoSQL database. If that database supports streams, it can inform other listeners or other systems that, hey, this data has changed. This is the information that changed. You can do whatever that you want to hook into there. So for example, AWS DynamoDB has the same functionality. Or MongoDB as well has change streams. I'm not sure if there's something else at that moment. Does anyone know anything, any other database that has streams? Cosmos DB. RethinkDB. Azure, what Azure has?
Azure has Cosmos DB.
Ah, okay. So Cosmos DB, RethinkDB. So that takes the workload off your back office system towards this NoSQL database, right? And it's probably hosted somewhere, blah, blah. But then again, you have more flexibility and more points where you can extend the functionality and generate read models from. the NoSQL approach is kind of good because you don't need to really track a lot of different projectors at the same time. You kind of, sorry, not the projectors, you don't need to track different sets of data that you update. If you save your whole product into a NoSQL database, then basically you can hook up all of your projectors on product updated and they pick out the data what they want. Because maybe in the back office you have a special place where the price is updated or something like that. If you have a situation where you need to bulk update data, of course, please utilize the queues. You know the queues, I guess, the SQS or RabbitMQ or Kafka, whatever. But then these queues will help to schedule big changes and help you to fix certain mistakes if they happen, right? If you have 50,000 products and you forget to add the title of the product, you want to fix it as soon as possible. And you don't want to kind of, again, hook up to your back office so that it's slow and slowing everyone down. Okay, I rushed a little bit with everything. So, if you have no injection points, if you have a system which you don't want to touch, maybe it's super old, maybe you don't have any code, maybe it's, I don't know, from 1999, if anyone has that, you can have different injection points, different triggers, how to trigger your projections. So for example, you can utilize triggers from the relational database, which might, I don't know, save data into another table, which you have a simple microservice that pulls that data and does whatever else it needs to do. So for example, triggers all the projectors. You can utilize slave replication as well if you have an old project. So replicate the data that you have in a relational database and then read and have a microservice that again triggers your projections to generate those read models. You can utilize webhooks as well. Have a service that listens, just make an HTTP call. So all of these can trigger your projectors to generate those read models. You don't need to take all of your system and write it in some kind of way that you know, it will take a lot of effort, but you can find this point somewhere if you think a little bit out of the box. It gets complex when you have more relations with the same information. And that's something to kind of keep in mind as well if you have a very complex project. Because you might have pictures, which is a relation to product, perhaps it's managed externally. You might have a price, which is managed externally. You might have some kind of alternatives, which is managed externally. So they're not part of the product, but they're kind of additional information in there. And when you have read models for all of these, you might use something like GraphQL, for example, but this is just a suggestion to kind of connect those relations together because you want them updated and you want them linked somehow together. So if you have projectors, you have projectors projecting read models for all of these sections on the product page. Again, you basically don't need any kind of relational database backend to display a product page. So start from the use case. Always try to start from the use case and look what kind of sets of data you're going to use in your project. How are going to display that information for users first, and then go towards the database stuff and how you're going to display it and etc. Don't start from the database structure, because then you're going to end up with normalized things and a headache inside of your project, how to query and how to index and how to make it perform in the front page. Try to start from the read models and then think how those read models are going to be projected. And if you have read models and projectors, you basically don't need any kind of cache, which saves you a lot of effort, a lot of headaches, and basically decouples you from all the problems of cache that there is. It is very hard. It is very hard to keep cache up to date, to keep cache structurally integral and correct. So I think that you don't need a relational database for user-facing content, because you can achieve that in a much, maybe not easier, but more performant way, and just by taking a different approach how you model your data. And that's it. Does anyone have any questions? Of course. Okay. So the question is, how do you work with personalized data? Basically, I work with a project that generates personalized timelines as well. And what we do, we generate the same read models for every single user. Whenever data changes that is related to those users, we just fire an event, and then we have workers which kind of generate all the content for them. So because storage is cheap, we can allow ourselves to do that. Any other questions? Okay, so the question is, how do you deal with the state inside of the projectors? Yeah, so the concern is that there are many states in the projectors. Okay. Eventually, your projectors don't keep any state. They're just...
The state is the HTML.
The state is the read model, yes. The state is the read model. You might have situations where you, of course, miss that update of the state, right? And this, I don't have kind of a direct answer for that. Most of the times, when you hook up it from the beginning, so when you save a product, that eventually should trigger your projector, which eventually will generate that state in the end. So if the projector breaks, of course, you will not have any kind of read model updated, but then perhaps there is a need of monitoring or something like that to know that information, because it's just one way. Usually you don't have any kind of feedback from the projector itself. So the good thing perhaps about this approach is that it's quite cheap to generate the information. So you can always, if you spot a mistake, you can quickly change it, regenerate it again, and you fix that mistake. So that state does not linger too long, as opposed, for example, with cached data. Does it somewhat answer the question? Any more questions? So the question is, what's the difference between cache invalidations and read models? Control. I think that's the main difference, is the control how you can invalidate the cache. If you have 10, 15, 100 web servers, probably you're caching somewhere locally, right? You don't do the network caching, because then you have network problems by reaching that. Maybe you do, of course. You can then validate that cache. But basically, from the projects that I saw, most of the times the cache is being regenerated by users. It's when the user comes into the website, into the product page, let's say, and then it generates the cache. As for read models, you are in control, and you can trigger the update of the read model only when the data changes, not when the cache expires. Any more questions? So the question is, how do you deal with structural changes in your read models? The way I dealt with it, we basically add new information into the read models. So we don't change the existing fields, let's say, or properties of the read model, because that eventually will break everything, right? So you might take it an API approach that you always keep your backwards compatibility with the rest, right? Please come to me afterwards because we're out of time. Please leave some feedback if you liked or if you didn't like my talk. Just drop some words, please. And I'll be at the speaker's corner there. So please come to me or find me around and we can chat afterwards. Thank you very much.